is a video explaining the 2.4 to 2.7 review questions in case you need some extra explanations. So I'm just going to walk through the problems and explain. So it says, using the diagram below, determine if the statements in number 1 through 3 are true or false. Planes Q and P intersect at line M. Well, here's plane Q, here's plane P. Well, anytime two planes intersect, their intersection is a line. That's one of the postulates we learned. So this is true. Let's look at the next one. It says line L and M are perpendicular. So here's line L and here's line M. And we don't know they're perpendicular. If they were perpendicular, we would have a symbol marking that. So that we cannot assume is true. So we will say false because it's not marked. And then the final question here, points B, C, and D are collinear. So let's look at points B, C, and D are collinear. Now it may look like they form a straight line, but there is no line drawn through them, so we have to say false. We don't know for a fact that they are collinear if one line isn't drawn through them. So there's no line drawn through. All right, let's move on to the next question. It says, provide the missing statement or reason for each step of the algebraic proof. So basically, we are starting out with this equation, and we are proving that x is equal to 5. And this is just normally what you would do when you solve an equation. You just do it automatically. Well, the first thing we do here is we multiply. And that's the distributive property. So you can see that it's saying the reason is distributive property. And so what our statement would be after we perform the distributive property would be 7x plus 28 plus 5 equals -2. Okay, now we're supposed to fill in the reason. Okay, we see from this step right here, down here, what happened? Well, this 28 and the 5 got added together to get 33. So when you add 28 and 5 together, what we're really doing is adding numbers, which is simplify. Or you could say add like terms or constants together. That's fine too. All right, so let's look at the next thing that happened. Well, from here to here, it looks like, this 33 is missing. Well, that's because we subtracted 33 from each side, and that's what gave us this -35. So that means we use the subtraction property of equality. And then last but not least, how did you get to that last step? Well, most of you know we just divided by -7. Well, that gives us the answer. It's the division property of equality. All right. Next piece says, sketch a diagram of postulate 10. If two planes lie in a plane, then the line containing them lies in the plane. So I'm going to start out with, if we have 2 points lying in a plane, I'm going to call this like plane R, then what we have is we have that same plane, and we have those same 2 points, but now the line containing them also lies in the plane, so I'm just going to draw a line through those 2 points. So there's an example. There could be lots of other examples that you could draw, but that's just one example. Okay, next set of problems. We're identifying the property illustrated in the statement. So it says angle TYV is congruent to TYV. Well, that's exactly the same. Well, duh. Of course they're congruent to each other because it's the same exact angle. And when it is exactly itself, we call that the reflexive property. And remember, the reflexive, transitive, and symmetric properties apply to not only equality or equal signs, but also to congruence or congruent symbols. All right, let's look at the next one. We have AB plus BC equals AC. Well, what in the world is that? Well, if you draw a picture to see what's going on, here you have an A and a B. And it's saying AB plus BC has to equal the whole thing AC. That is our segment addition postulate. Next question. If the measure of angle 1 is congruent to the measure of angle 2, and the measure of angle 2 is congruent to the measure of angle 3, then we have 1 is congruent to 3. That is our logic chain. That is transitive property. And the last question says, if AB equals AB, then WX plus AB equals YZ plus AB. So what's happening here is we have the same value right here. And what we are doing is we're adding this equal amount right here to these segments. And when you add equal amounts, you get the addition property of equality. And you don't need that equality piece, that's fine. All right, well, let's try this. Let's try walking you through this proof. All right, it says given that angle ABD is congruent to angle CBE. So ABE, that's this angle right here, is congruent, so I guess I'll mark that right there, is congruent to CBE, which is this angle right there. So that's given, and that's marked right here with those tick marks. So those are congruent. We're supposed to prove that EBA, so EBA is the measure is equal to the measure of DBC. This is our overlapping angles. And it kind of makes sense, okay? But let's prove it. All right, so the first statement is supposed to be our given statement. We can see that it's given us the reason. So I need to write this given statement. So I'm going to write that angle ABD is congruent to angle CBE. That is given. Now we've gone to, oh, the angles are congruent. It says the measure of angle ABD is equal to the measure of angle CBE. These are almost exactly the same. Okay, they're so similar, and this is such a picky little piece of geometry, but basically we know because of definition of congruent angles or segments that when we say they're congruent, it means they're the same, equal value or measure. So in this case, we're going to say that the measures are equal because they're congruent by the definition of congruence, or we can say congruent angles. But you could really just say the definition of congruent, that's fine. So now let's look what happened here. We have, well, let's get a different color here. We have our ABD and our CBE, and you can see that those are right here. And notice what's happening is we're adding the same angle measure to each of the equal angles to start with. So that is our addition property of equality again. We added equal amounts to the equal sign. All right, well, what happened here? Now we have that EBA, that's this yellow angle we marked, so EBA right there is equal to the measure of angle ABD, so ABD, plus DBE. So we're just adding these two pieces together to make the whole, and that is our angle addition postulate. All right, well, now they're like, hey, giving us a reason, there's another angle addition. Well, that's because it's for this angle right here. Whoops. That is for this angle right here that is named DBC. So we're going to put in here that the measure of angle DBC is equal to the two pieces right here, here and here. So we can name those angles as the measure of angle CBE plus DBE. So we've got angle addition twice. Great. All right, well then how did they get, you might be asking, how do we get, how'd they go from here to here? And this is the whole thing about proofs. We use the information above to make a logical argument, kind of like a logic chain. And if possible, you try to put the logic chain in order to make it be more sensible. Of course, you can still figure out the conclusion without having it in order, but it takes a little more effort. So we try to put things in order. So what happened here? Well, we have EBA, okay? That was this yellow angle right here. We have EBA, the measure, okay, and is equal to DBC, okay? That's what we highlighted as this green angle. So where did these things come from? Well, how did you get from there? Well, look at EBE right here is equal to ABD plus DBE. Do you notice that right up here? These are the same. So we can substitute what these two angles add up to. They equal this, and we can substitute it in here. And that's where we got this. We substituted what the measure of angle ABD plus the measure of angle DBE was equal to, which is this right here, the measure of angle EBA, and put it in. And the same thing happened down here. So notice that this CBE plus DBE is the same as this right here. So we can substitute what that was equal to in here, which gave us this right here. So now we have proven that our original statement that we set out to prove is true. So we have proven that the measure of angle EBA is equal to the measure of angle EBA is equal to the measure of angle DBC. These are the same. That's what you always want to end your proof. But how did we get that last statement? What allowed us to say that? And that is called substitution. Okay, we have one more question to go through and explain. All right, it says solve for x and y. Well, you can see right here that we have, for x, we have a linear pair with these two angles. And these two linear pairs, the linear pair postulate says they're supplementary. So that means that 2x plus 6 plus the other angle, 3x minus 21, adds up to 180. Now we combine like terms, and we combine constant, the 6 and the negative 21, to get negative 15 equals 180. Now we add 15, and we get 5x equals 195, and then x equals 39. Now let's work on the other y values. All right, so the y values also right here form a linear pair. So they are also supplementary. So 7y plus 5y plus 36 is equal to 180. Combine like terms. Use the subtraction property of equality to subtract 36 on each side. Divide, division property of equality, and you get y equals 12. All right, hopefully that helped you review the last half of chapter 2. This is the end then of our explanation of the review.